Welcome to Improvement Science in a Minute. I'm Brandon Bennett, and today we'll be introducing the run chart, a key tool for understanding variation and detecting when changes occur in systems. The Improvement Science in a Minute web module series is brought to you by the SELPA System Improvement Leads project in partnership with Improvement Science Consulting. Our learning objectives for this module are appreciating why observing data over time can be helpful for managing a process or system, and learning one way to analyze time-ordered data to build knowledge about the performance of a process or system. Within every system, we can expect some variation, day to day, person to person, event to event. For teams tasked with improving their systems, a key question they need to answer is, what do the differences mean? The run chart is one tool helpful to teams in answering this question. It helps teams detect changes in their systems and determine when these changes represent an improvement. What does a run chart look like? It looks like a line graph, with a measure of interest, baseline data, a median generated from the baseline data, and extended into the future to help interpret future data. Importantly, the data is plotted in time order. We can contrast a run chart with the point-in-time data, such as that used in many dashboards, like this one from the California School Dashboard, describing performance for the suspension rate in the state. Point-in-time data is collected from everyone at the same time, often aggregated and used as a comparison to a different point in the past or to compare different groups to each other. Different from comparison, data presented over time offers an opportunity to make meaning of what may be happening in our systems. Take, for example, the suspension rates from the previous slide. When we look at one point in time compared to another point in time, our interpretations are limited. Here, the data looks like suspension rates are staying about the same. But when we look at all the data we have available, we realize that suspension rate has actually been decreasing over time. Let's take a look at some additional examples. In these illustrative examples, each graph displays the same 8 data points, suspension rate for each school year. Each displays the same median performance, 4.42%. But at a glance, it is easy to see these graphs tell very different stories, each story leading to a different set of decisions about what to do. In the first chart, in the upper left-hand corner, we see that suspension rates are decreasing. Here, school leaders would want to keep the focus, keep improving, and maintain existing resources. In the second chart, in the upper right-hand corner, leaders might recognize a steady overall state and launch improvement if a better outcome is desired. While in the third chart, suspension rates are clearly increasing. Leaders should worry about what is happening, launch work to investigate and improve, and commit resources to the effort. The time order of these charts reveals these stories graphically in a way that point-in-time data cannot, therefore assisting teams in determining if our change is in fact an improvement. At the heart of learning about and improving systems are questions. The questions we choose to ask can have profound effects on what we learn and how quickly we are able to improve our systems. For example, is Group A different from Group B is a very different question than, how is Group A's performance varying over time? The first question is about comparison and judgment, while the second question is about managing and improving Group A's performance. Sometimes we want to learn from comparisons, but often it is more helpful to learn from variation in performance over time. Here are just a few examples of scenarios where asking the second question is so valuable in education. Examples include, how is attendance varying over time? How are office referrals varying week to week? How are suspensions varying month to month? How does district's response time to school requests vary from month to month? How are ELA scores varying from year to year in the district? How are graduation rates varying in the district or at a school over time? Generating a clear learning question helps us determine what data we need to create our run chart. Improvement of systems is all about learning, and the crafting of learning questions is a critical step in building understanding about where and how to change a system to accomplish the improvements desired. On the previous slide, we have given you examples of learning questions. Now, can you identify 1 or 2 learning questions for your system where understanding variation over time would be important? What would be the measures connected to your learning questions? Take a moment to pause this video and reflect on these questions. Welcome back. The duration between data points is called the interval, and the length between can have a substantial impact on our ability to learn. When data is collected yearly, as with the state-level suspension metrics we just looked at, we must wait many years to develop a run chart we can learn from and act on. More frequent intervals for data collection and reporting allow us to learn more quickly, and thus to take corrective action to improve or repair our systems. For example, how many students are suspended on a monthly basis, or how many students are referred to the office on a daily basis. With your learning question and measures now drafted, I encourage you to pause again. Reflect on these questions too. What is the interval with which data is collected for each measure you identified? Based on this interval, do you expect your learning to be fast or slow in developing? Connected to the measures you identified, is there an equity lens you could apply? For example, does performance differ for different student groups over time? If a gap exists, does it persist over time? The clearer your question and measures are, the easier it is to construct a useful run chart. With these considerations in mind, take a moment to refine your learning question and measures. Welcome back. Now let's take a look at the steps to create a run chart. With learning questions, measures, intervals, and an equity lens in mind, we now turn our attention toward how to make a run chart. Here we present 7 steps for the creation of a run chart. Please note, these steps are also summarized in the supporting handout. Let's take a closer look. Step 1. Form a learning question that is best answered using data over time. Step 2. Develop the scale for the x-axis. Step 3. Develop the scale for the y-axis. Be careful to keep the data displayed in the middle third of the chart. Step 4. Plot the data values. Step 5. Calculate and place the baseline median. Extend it into the future as a prediction of future performance. Step 6. Label the run chart. Add important detail to the x-axis, y-axis, and chart title. Finally, Step 7. Annotate the run chart with any additional information. Adding words to the chart can really help in communicating the story presented through the data. Here we have annotated the end of the baseline data collection period. Remember, these steps are all included in our handout, 7 Steps for Making a Run Chart. If you're wondering how to format your data in a spreadsheet to make a run chart, take a look at this example. X-axis data is located in column A, while y-axis data is located in column B, and data for the median is placed in column C. Organizing your data in this way will allow you to quickly use the line chart function in your software to make the run chart you need. It also affords you a place to collect new data to add to the run chart as it becomes available. Systems and processes vary over time. The run charts we make clearly show us this. But is the variation we see important? How should we interpret the variation? What learning can we pull from it? How can it help us to know when a change is an improvement? We turn now toward these questions. For leaders, the ability to know what performance to expect matters. Run charts can help us define expectations. But equally valuable is the ability to distinguish whether the variation we observe is random or non-random. The presence of random variation in the data is what we expect from systems which are not changing. If things stay the same, then observed variation in the future will be randomly distributed around the baseline median. The presence of non-random variation, then, is an indication that some change is taking place. Is the performance over time what we want or expect from our system? Is the variation we see in the data random or non-random? Consider how these questions interact and why they are important to the management and leadership of systems. Rule 1 is known as the shift rule. A shift occurs when 6 or more consecutive data values fall above the median or below the median. Data points falling directly on the median do not count towards the presence of a shift, nor do they count against the presence of a shift. Rule 2 is known as the trend rule. A trend occurs when 5 or more consecutive data values are either all increasing or all decreasing. Trends are relatively rare because of this requirement. Rule 3 is known as the run rule and refers to the frequency with which the data line crosses the median. Each time the data line crosses the median, a new run of data is said to begin. When performance is random, the number of expected runs varies depending on the number of data points present on the graph. When there are too few runs, fewer than the expected range, then performance is said to be not random. This can also occur when there are too many runs. Often this looks like a sawtooth pattern on the chart. The handout provided details the how many runs are considered to be random depending on the number of data values available. It serves as a good reference for any team interpreting their run chart. The final rule for detecting non-random variation is known as the astronomical value rule. This rule is not based in probabilities as the other rules are. Rather, it is linked directly to subject matter knowledge of the performance of a process or system. This rule is indicated when a single data value is blatantly, obviously different from all other data values. Often someone with knowledge of the system can quickly explain why the data value is so big or so small, and not random. Remember, we've included these rules for detecting non-random variation in our handout, 4 Rules for Interpreting Run Charts. Using measurement for improvement and run charts in general can be challenging. When getting started, it can be very helpful to formulate the learning questions that can inform improvement, sketch the chart that can answer those questions, and craft the database that can create the chart. Even a simple sketch can greatly ease the burden of figuring out how to use measures for improvement. Take a moment to pause and reflect. Welcome back. With your learning questions crafted and your chart and data tools sketched, you're ready to create your own run chart. Interested in learning more about improvement science? Visit our website for more content and to access additional modules. The Improvement Science in a Minute web module series is brought to you by the SELPA System Improvement Leads project in partnership with Improvement Science Consulting. The SIL project is a collaboration grant project between El Dorado County Office of Education SELPA, West San Gabriel Valley SELPA, and Riverside County SELPA. The SIL project is supported by the California Department of Education and the California Collaborative for Educational Excellence. The SELPA Systems Improvement Leads project seeks to increase positive outcomes for students with disabilities by inspiring special education local plan areas and local education agencies to engage in a culture of continuous improvement. The SIL team is committed to connecting SELPAs and LEAs throughout the state to resources with a focus on data use and governance, continuous improvement methodologies, and high leverage practices. We are innovating with equity in mind to promote excellent educational outcomes for each and every student. Thank you for watching.